Hi, and welcome to the Unreal Engine News and Community Spotlight. Earlier this week, the Academy of Motion Picture Arts and Sciences, together with the Linux Foundation, launched the Academy Software Foundation. It's a nonprofit organization designed to provide funding, structure, and infrastructure for the open source community in the motion picture industry, and we here at Epic couldn't be more pleased to be a founding member. The widespread use of open source software has created challenges, including siloed development, managing multiple versions of OSS libraries, and varying governance and licensing models that need to be addressed in order to ensure a healthy open source ecosystem. The mission of the ASWF is to increase the quality and quantity of open source contributions by developing a governance model, legal framework, and community infrastructure that lowers the barrier to entry for developing and using open source software. Developers interested in learning more or contributing can sign up to join their mailing list, link included below. It's been a busy week for our teams out at SIGGRAPH. In a breakthrough demonstration, NVIDIA CEO Jensen Huang revealed the speed of light, a real-time cinematic experience utilizing NVIDIA Turing architecture, RTX technology, and new Unreal Engine rendering advancements, featuring the Porsche 911 Speedster concept. The forward-looking technology unveiled on stage is the culmination of a joint development effort to unlock offline quality, ray-traced rendering in a game engine. The Speed of Light demo debuted running on 2 NVIDIA Quadro RTX cards with new Unreal Engine features, including ray-traced translucency, ray-traced rectangular area light shadows, ray-traced reflections, ray-traced diffuse global illumination, and dynamic textured area lights. Read more in the link below. Earlier this year, at GDC, we partnered with 3Lateral to reveal a stunning development in real-time human-driven digital characters featuring Andy Serkis. This Tuesday, 3Lateral unveiled the next iteration in this story. Watch as Osiris Black seamlessly morphs into digital Andy while being driven by the same Macbeth performance. 3Lateral's comprehensive technology framework uses UE4 to power 4D volumetric capture and empowers much more than just extraction of data for animation. It provides detailed info of the facial deformations and motions to build fully valid animation curves, a next-generation process compared to 2D and 3D facial tracking and solving. This gathering of annotated data and level of photorealism have wider implications for machine learning and can be applicable in entertainment, biometrics, medicine, and many other fields. We're blown away by 3Lateral's capabilities and look forward to seeing what they're able to achieve next. We're happy to introduce the Unreal Engine online learning platform, the new home for all our training series and video tutorials. Our extensive online training illustrates common workflows in a series of detailed yet easy to follow videos so you can master UE4 for your own projects. This new platform includes a lot of the great video content you've already seen on our website, plus dozens of new videos on common workflows, new features, and a whole lot more. The content is split into several tracks, such as area of focus or job role, with all content labeled for experience level. The learning platform is open to everyone, offered free of charge, and more content will be added regularly. Access the Unreal Engine online learning platform through the video tutorials option under the Learn tab on our website and get started today. Motion Builder has long been a favorite of character animators, whether working with motion capture data or animating by hand. Now, with the Motion Builder LiveLink plugin, there's no need to export and import MOBU data to Unreal Engine while you're working. You can stream MOBU motion capture and animation directly into the engine and preview it in real time. The plugin works with Unreal Engine 4.19 and above and is offered free of charge. To get the plugin, download Motion Builder LiveLink from GitHub. For information on installing and using the plugin, see the connecting LiveLink to MOBU topic in the UE4 documentation. And if you have custom external software or hardware that you want to interface with Unreal Engine, you can write your own plugin that integrates LiveLink and gets all the same benefits. And you can see our LiveLink plugin development guide for details on that. On to our weekly Karma earners. These folks are jumping into AnswerHub and helping out their fellow devs. So we'd like to give a huge shout out to everyone, Everynone, Dijo, Spiter, Thompson N13, Nebula Games Inc., Shadow River, T. Sumisaki, Mighty Enigma, Redbox, and Aussie Burger. You guys are the bomb. So our first community spotlight is a project by Nazir Sani. He created this gorgeous New York living room environment. It was created in under a week and he's put together just a really fantastic scene. It's really incredibly realistic, well lit. It looks fantastic, so great work on this project. Our second community spotlight is it's called Distributed UE4 Dedicated Cluster Technology. So Jin has created this technology, short DAT, and it allows you to distribute actors across multiple dedicated servers. And they all interact as if they were on the same server. The intent behind distributing the game across multiple servers is it allows you to build more robust worlds with more actors and with AI as intelligent as you can make them. The API is provided from within a standard UE4 plugin and use is similar to standard server development. So it looks like Jin has created some real interesting technology here. He's also looking for additional feedback or even folks to get involved with the project, so you can join his Discord server to do so. Our third and final community spotlight this week is a project called Walking with Dinosaurs. So Artist in Motion has just recently finished this short animation as part of a recent revival of Global Creatures Walking with Dinosaurs, the Arena Spectacular. There's a 3-minute long sequence that takes you across 6 different Cretaceous area landscapes on a continuous camera move. So it's a really visually stunning project, and I hope that they'll share the video with us sooner than later, because I'd love to see all this in motion. All right, thank you for joining us for our news and community spotlight. Hey, and welcome to our Unreal Engine live stream. I'm your host, Amanda Bott. With me, we have Jay Hosfeld returning, lead animator, and Jim Slaker, fellow community manager. So thank you all for joining us. I know you're all very excited about Jay discussing the turn in place. It's been a hot topic for quite a while.
Yeah, we've been putting it off for a little bit, but we're doing it today. It's going to be cool.
And then, so Jay will dive in just a sec. At the very end of the stream, we'll be doing some Summer UE4 Jam kickoff, so the theme will be announced at the end, so you will have to learn a little from Jay before diving into your own game jam. So I hope you're excited, though. But yeah, feel free.
All right, so let's start. So this is
the moment.
If you guys have been watching my prior streams, I think this is number 5 now.
Yeah.
I've been doing pretty kind of relatively small stuff, bite-sized stuff. This one is far more complex. So I'm going to try to break it down for, I assume a lot of you out there are like, say, an animator like me or not a programmer, so I want to break it down into kind of easier to understand chunks. So first of all, let's just start here. I'm starting with the Shinbi package we have in the marketplace. I downloaded her as is, but from a starting point, there are a couple things we need to change on her. So for this demo, I actually wanted to go with our strafe system and not run into your direction system. So again, I covered this on a prior stream, but I'm going to go over it again. So on the Shinbi player character, what we want to do is use controller rotation yaw. We want to turn that on. And then when we go to character movement, we want orient rotation to mouse to turn off. And so let's go ahead and play this and see if I'm getting the behavior I want. Okay, so this is the behavior I want. Right now she's not going to stay put when I turn. And this is where we want to insert the turn in place animation. If she's running, I don't have the strafe plugged in, but we would, on the last stream I had plugged in the strafe, but for today we're going to skip that part. But for now, we have her rotating in place. And so when you bring up a question like how do you turn in place, like if an animator asks that, it's actually a more complicated question. And what you want to do is break that down into like smaller bite-sized chunks. So really, right now we don't even want her to turn in place. We actually want her to kind of keep her feet locked and have the rest of her aim, like use the aim offset to look to her right or left. And I'm going to show collision. And I don't know if you guys can see that on the stream, if you guys can see her capsule or not. It's kind of thinly drawn. Let me go to full screen here. But you can see this capsule. So when I turn the mouse to the right or left, that capsule is moving, and we actually want her to offset from that capsule. So getting back to how to break down a problem, the first step I want to do is how can I offset her from this capsule and keep her looking straight. So to start here, we're going to open up her animation blueprint. What I would recommend, like I've said before, is duplicate your animation blueprint, and that way if you mess up, it's okay, you have one to start with. So I've already duplicated one, and I'm calling it turn in place stream anim blueprint. And I want to go ahead and hook that in to the blueprints, the character blueprint. And it looks like I've already connected it here, so we're good to go. I'm actually done with the character blueprint for the rest of this.
And that was under
this
anim
stream.
class, right?
Yeah, that's under anim class right here. Okay, so let's get back to our blueprint. So here is the blueprint that my character blueprint is using. This is the anim blueprint it's using. So what we want to do is we actually just want to rotate the root node. And there is a node in here called rotate root node, or rotate root bone. So on this node, we only want to worry about the yaw. So I'm going to go ahead and turn off the pitch. I'm going to turn off everything else. And we're going to feed that in to the rest of our stream. And so off this yaw, let's go ahead and create a new variable. And let's call this, sorry, let's create it first. Promote to variable. And we're going to call this root yaw offset. All right, so this root yaw offset in today's demo is this thing is the most important thing. We are going to be changing the value of this different ways, and that is always going to change the root bone. So let's go to the event graph and start getting to a point where we could feed in different values to this thing. So one thing we want to do just to kind of get this event graph in order is when I changed our character to orient with the mouse, we are now in a situation where we're not going to get a delta between our aim rotation and our actor rotation. So for the Shinbi you guys downloaded, we can go ahead and disconnect the delta, and we're actually just going to go ahead and feed in actor rotation right into the brake rotator. We're not going to worry about base aim rotation at all. Okay, so we have that in order. Okay, so let's go ahead and we want to be able to set our root yaw offset. Okay, so let me find a good point in my graph to add this. So let's go to, we'll add it here. Okay, so I'm going to drag and drop the root yaw offset over here, and we want to set this. So we only want to change this value of root yaw offset when we're idle, when we want to turn in place. We don't want to set it when we're running or if we're playing a montage in Melee. So what we want to do is let's go ahead and add a branch here, and basically this is going to be a true branch where if any of these things are happening, we're going to always keep this root yaw offset at 0. We're not going to rotate the bone. So let's think of the scenarios where we want this. So is accelerating, we don't want to do that. Let's say if speed is greater than 0, we don't want to do it. And we also don't want it to do it during our melee. So let's set up a real quick.
What about during a jump?
Jump's fine because you will be moving.
Oh.
Yeah, during a jump.
Or be accelerating.
Yeah. So let's go ahead and create a new variable. Basically, let's say if any montage is active, we will not do this. So there's a node here. We can say, is any montage playing? If that montage is playing, let's just promote that to a variable, and let's call this is montage. And so right now we're just kind of setting up some of the things we need, some of the information we need to do the logic of turning. And this will all start making sense here in a little bit. Okay, let's go ahead and plug that in here. Okay, so now we have a new variable is montage, and then we'll put that in our list here. Okay, and we're going to go ahead and make a or bool. An or boolean. So what we're saying is if you're accelerating, if your speed is greater than 0, we'll add a pin here. And if montage is playing, looks like I added a little extra character on that, but it's fine. So basically, if any of these are happening, it is therefore true. And we're going to set root yaw offset to 0. And we can go ahead and start feeding this in. So that's actually the easy part. Now we actually want to figure out what to do to the root yaw offset. When you are idling, what are we going to do to it? So basically what we want to do is we want to look at your yaw value. That's like the direction you're facing in the game. And then as you turn the character, we want to get that difference. And we want to keep accumulating that. So if you turn right to the 90, we want to get that 90 number and apply it to the root offset. So if you turn 90 positive, we want root yaw offset to be negative 90. And that's going to keep your character still. So let's go back up to the yaw. So earlier, this is why I said we should probably get this in order. What we want to do is go ahead and set a yaw last tick variable, and I will explain. I'll explain how we'll use this. All right. So this is going to be called yaw last tick. And we actually want to set this first. So off the break rotator yaw, this is up in the set roll pitch and yaw section. We want to go ahead and set yaw last tick. Then we're going to set our yaw. And we don't want z yaw to feed into yaw last tick. We actually want what we set over here to tell what yaw last tick was. So let's go ahead and we're going to get the yaw information here. And we're going to go ahead and pull off pitch. So the order of operation is going to, like, set pitch. It's going to set yaw last tick. So when yaw last ticks, it's going to basically just look at this value. So let's say this value is 10. This is going to be set at 10. Whereas now with the new frame, yaw is getting its number from the break rotator. So that might be 12. So we now have two variables we can get a delta from. So let's go ahead and drag off here and go ahead and get that delta. So we will get yaw last tick, and then let's do yaw. Let's go ahead and subtract the 2.
So they're asking, is this the same way that it's done in Fortnite?
This is done, yes. This is, I think, pretty much the same way in Fortnite that it's done, yeah. Actually, I'm not bragging at all, but this way is actually a little better in Fortnite. So I'll go over that in a little bit.
Shots fired.
But I do want to say Ray Arnett, who set up the Fortnite system, helped me on this one. So it's all fair. All right, so we're getting a delta between these two numbers. And let's say right now it's like, say, 2 per frame is what it is. But funny enough, if you look back in this blueprint, I've already set the yaw delta just to get our leans. But this has an F interp on it. I need one that's instant. So I'm going to go ahead and basically essentially make a different kind of yaw delta. So let's just promote this, and let's call it, essentially it is a yaw delta, but let's just call it yaw change over frame. And that's essentially what it's doing. Okay, let's go ahead and feed this in. And let's feed this into here. Okay, so now we have yaw change over frame. And this is the number that we want to continuously keep adding to our yaw offset, our root yaw offset. So this is set. So these variables are set. Let's go back down to where the action is going to happen. So remember, this is where I set up the branch, where we don't want the root yaw offset to do anything here. Let's go ahead and duplicate this. Now this root yaw offset number is going to change all the time because we will be in idle mode and turning. So what we want to do is get that yaw change over time. And just like we did to get the yaw delta, we're going to add it to root yaw offset. And again, what's going to happen, I'll kind of talk through the kind of the order of operations is, let's go ahead, and this is going to be false. We'll feed it into here. So if you guys can see my mouse cursor. So what's going to happen is the root yaw offset number is going to come through here, and let's say that's 90. And we set it. Root yaw offset is now 90. So over here, it's going to, root yaw offset that's set at 90 is also going to add to the yaw change. So let's say now it's 92. Well, now 92 is now setting the new root yaw offset. So think of that over frames. That 90 is going to become 92, 94, 96. One thing, too, is when we're dealing with yaw, it's going to give us a number between like negative 360 to 360. You can get pretty high numbers. What we want to do is go ahead and normalize axis. And what this does is it basically gives you a full 360 degrees with negative 180 is one range and positive 180 is the other. So let's go ahead and put in a normalized axis here. All right.
And
so
is that just kind of saying between this range is kind of facing forward, or?
This is basically taking, you know, imagine negative 360, you know, when you're doing a circle,
Right.
negative 360 is the same as 0, right? Or
Right.
negative 180 is the same as 4, I can't do the math that fast, but you
Right.
get what I mean, right? So it's normalizing it. So that way your min and max is 180.
I got you, okay.
So theoretically, this should all be working. Let me make sure all my connections are set here. All right, I'm going to compile. Let's go ahead and save. All right, now if I play, expectations are that she is going to stay in place. There we go, look at that. She's staying in place now. If you guys remember earlier, she would move with the capsule. So if we show collision, so now the capsule is actually rotating, and look at her feet. Her feet aren't sliding anymore. She's staying locked. So all we did there is we didn't do turn in place. We did the first step of the problem. We had her counter what the mouse is doing. So we need to do a couple things now. So I did change the way the yaw works, and you know, if I were to go back and play this, this will really show you guys, is the yaw was driving the aim offset for her. Now if I run around, you can see that yaw is doing some funky stuff, and so she's kind of looking around while she's running.
Somebody wants to know what the yaw changeover frame is.
That was the variable you created, right?
Yeah, yaw changeover frame is a variable. That's basically getting the yaw and then comparing it to the yaw last tick.
Okay.
And I can, if I have time for questions, I could always scan over
No worries.
the graph. Okay, so what I want to do is go to her aim offset in the anim graph, and I'm just going to disconnect yaw. And for those who haven't seen what aim offsets are, basically it's just a series of poses that I could feed in a rotation value to change, you know, where she's looking. That's an aim offset. Okay, so I'm going to go ahead and disconnect yaw. I'm just going to straight up delete it. Okay, so now if I play the game, she's not going to look around at all. She's just going to stay straight. All right. So now our next option, which is a little bit even more complex, is we want to get her to turn in place, right? So let's, first of all, let's just go back to our event graph, our anim graph. We're going to go to the anim graph. we're going to go into her ground locomotion state machine, and we're going to go into her idle state. And we're actually going to make a nested state. So you can put state machines in state machines. And we're going to call this one idle and turns. Okay, and this is going to feed in. And so I'm going to go ahead and copy this play idle because I'm going to use it here in a second. Okay, so now I need to make a new state, and I'm going to go ahead and make that idle state again. It won't let me rename it. Hold on. There we
Is
go.
it being difficult?
I thought the keyboard battery went out for a second. I got
Ooh,
scared.
That would be exciting.
All right, so then we're going to make another state, and this is going to be our turn states. Okay. So in the idle state, we know we're going to play the idle animation. It's pretty normal. We're going to let it loop and everything else. In our turn state, we can play either the right turn or the left turn. And we're going to use the turn 90s, turn 180s. So we have our left turn and we have our right turn. And we're going to do a blend by bool, because basically we're going to say whether your root rotation offset is negative or positive, you'll choose either right or left.
Makes sense.
So true is going to be left, because when you turn right, you're offsetting your, if you turn right positive, your offset is going to be negative. So let's go ahead and get our root bone yaw offset. And if this is greater than 0, we will go ahead and choose turn left. Okay. Now in our state machine, we need a rule to get here. So if we go into here, again, like our most important variable we made is this root yaw offset. We're going to get this. If it is greater than 90, we want to go ahead and go into a turn state. But it is possible to get a negative 90 or positive, so let's go ahead and put an absolute value. And this will just make sure that number is 90 regardless of whether it's negative or positive. And we'll say once it's greater than 90, we can go ahead and go into the state. All right, we need to go back to the turns. So one thing, for the transition, I'm just going to give it a very small blend. I'll explain why later. For our turns, we want to make sure these don't loop. So let's go ahead and turn off loop. Okay. And then once you're done turning, we'll just go back into idle. So let's go ahead and just do automatic rule. And that basically says play out the animation, then return. Go ahead and move out of that state. And for turns, we also want to always reset on entry. Okay, so now what we should see is we should see her play a turn animation when she turns 90. So I'm going to aim 90, and she played a turn animation. So she is playing an animation. However, you can see she's not turning.
Right. She's playing the animation, but
she's playing the animation,
actually moving.
not turning. The reason she's not turning is if you look at the animations we authored, let's go ahead and pull up one. If you see the animations we authored, you'll see like the animator takes that rotation out. Once we animate it in Maya turning 90, we actually back that 90 degrees back out of the turn, because the game capsule is actually doing that 90 degrees for you, and you don't want to double turn. But what we do on Paragon, and this is why I said this way is a little bit better than Fortnite, is because in Paragon we have the concept of these distance curves. So what we've done is you can see the curve the animator used to back out that rotation, we've actually made it a distant curve on the animation. In Paragon, we use this to control how fast you rotate. How are we on time, by the way? Good?
Doing good.
All right. So we're actually going to use this to dictate our turn rate. And one other thing, I'll get to this. Okay, so basically you'll notice each turn animation has this in it. So one thing, the animations we shipped with to you guys have super long settle portions to the animation, which is something Paragon could use, but we don't need that here. So what I'd recommend, if you're going through this along with me, or if you want to do it later, go ahead and get to about the 1 second mark, and we're going to go ahead and remove frames beyond 31. So the turn will last for about a second. And let's go ahead and do that to the turn right. Go ahead and remove frames 31 to 60. Okay, so now both animations are just about a second long while we have these open. Okay, so let's go back to our event graph. And we're going to essentially start a whole new section here. So what we want to do is modify our root yaw offset based on that distance curve. And so what we're going to do is we're going to get a new branch, because basically we only want to do this if you're actually playing a turn animation. Okay. And so basically we need something to tell us this is true, that we're turning. Right now we have nothing, you can see in the variables, we have no variables telling us that we're turning. So let's go ahead and come up with a way to do this. I'm going to go back to our animations. And basically we can say, if this animation is playing, we're turning. So let's set that up. So we have this cool thing here where you can add metadata. So I'm going to add a new curve, create new. And we're going to essentially call this is turning. Okay, and let's load up the turn left 90, and we're going to add that same metadata. This time I don't have to say create new. It is now part of the list of curves. Okay. So if I go back to my event graph, I can now use a get curve node. Get curve value. And the curve name is turning. And I'm going to use a node you guys actually taught me about. You guys asked me why I don't use it, and then I looked into it, and it's a very good use, and it's nearly equal to node.
Oh, I remember.
Because sometimes you get those weird 0.00 ones. So let's do a nearly equal float. So basically we're saying if the animation has that metadata, what that metadata is doing is essentially saying that curve has a value of 1 throughout the whole curve. So I'm going to go ahead and say if it's nearly equal to 1, because you do get blends and stuff sometimes, and we'll just give it a threshold of 0.001.
I love that that's just an option. It's like nearly.
Yeah, it's
nearly.
Like, it's close.
It's almost there. Ish.
Ish.
The equivalent of ish.
So we have this branch condition, and then if this is true, if you are turning, we're going to do a few things. So we also have, like I said, the distance curves. So these are curves we want to look at as well. So basically we're saying if you're turning, we're looking at the is turning curve. Yes, you're turning. So now since you're turning, we want to look at those distance curves while you're turning. So let's go ahead and get get curve value node again. We're going to plot that down, but this time we want that distance curve that's playing. So off this branch, we're actually going to do a sequence of events. We need to do a sequence of events because we're going to be getting a delta on these distance curves as well. So let's add a sequence here. And for now, we're actually going to skip the then 0. That's the first node off the sequence. We're actually going to go straight to then 1. And actually, before we do that, let's go ahead and pull off this curve value. And we're going to set a new variable right here. So this variable is going to be called curve. We'll call this just curve value. I guess I should have called it the distance curve value, but this is just the curve value that's set into our turn animations. And we want to go ahead and also create a curve value last frame. So think of this just like we did the yaw last frame. We want to go ahead and duplicate this. We'll call it curve value last frame. Let's go ahead and set that. Okay. And then what is setting the curve value last frame is going to be our last tick of the curve value. And so again, if we were to run through this, and let's say the curve value is 0, it's set. Then we go through on the next frame of the animation, and now the curve is like 5. It's going to have the delta between the two. The curve last value and the curve value will have two different values. So then we can get a delta between those two. The do once, or sorry, I'm going to show you what we're going to do on the then 0 part. We're actually going to add a do once. And so this is because when you first start your turn animation, there is no distance curve to compare with. You're actually going to get, you're basically going to get a delta between 0 and 90 on that curve. It's going to do a big pop. What this does is it says the very first frame you enter that turn animation, you don't have to look at the last frame. And so on this one, we're going to go ahead and just go ahead and set the curve value. And basically, if the branch is false, we're going to feed that into the reset do once. Okay. All right, so we got a curve value. So this is, now we're going to set our root yaw offset again. So let's go back to this guy. Like I told you in the beginning, we are going to be updating this value a lot. Okay, so we're going to set this guy. And then this guy is going to have essentially where we want to do the curve last value. Let me drag and drop these. We're going to do curve value last frame. With the curve value. And we've done this concept 3 times now where we've gotten a value last tick. So this is a pretty important concept here. And we're going to go ahead and subtract these two. And once again, so this value here, imagine over the course of one frame, but comparing the curve, that distance curve on the turn animation, let's say you get a value of like 2, right? So we have a number coming out of here let's say it's 2. So what we want to do is get this root yaw offset that we had currently, and we're going to go ahead and get that value, and we want to subtract. So let's say like you looked 90, right? You turn 90, you looked 90. The root yaw offset now has that number of 90. But as you play your turn animation, you want to slowly subtract each frame. You're subtracting like say 2 per frame, 2 degrees per frame until you're back down to 0. So that's what we're going to do here is subtract. Going to subtract the root yaw. And we're going to update the root yaw offset. So we're getting near the end, guys, believe it or not. We're getting close. Right now I have nothing feeding into my branch graph, so let me go ahead and find a good point to do that. Okay, let's branch off here. Okay. All right, so we have everything flowing through once again. All right, so let me just double check. I went through this kind of quickly. Let me double check I have everything hooked up. Okay, curve value, our distance curve is getting the delta between these two. Then the root yaw offset is going to be slowly subtracting, essentially per tick, the delta of these two. And then we'll have a new root yaw offset that's set at the very end of the graph. So let's see what happens, Tim. What do you think is going to happen?
It's going to get turned.
It's going to get turned. Something's going to happen. Something's going to happen. All right.
I've been waiting to use that joke for like 40 minutes.
Dude. All right. So she's turning left, and
oh,
all right, she turned. She did something.
That was
right.
That was very abrupt.
And she's turning there. Cool, cool.
And her dangly bits are
right.
flying all over.
So what happened there is those curves on our animations are 0 to 90. Whether you're turning right or left, it's 0 to 90.
Right.
So what we actually want to do is put a multiplier. So if you're turning, let's say if you're turning left, you want to put a -1 multiplier on those curves. So let's go ahead and add a multiplier to, let's see, curve last frame. Let's go ahead and multiply this by 1 or -1, depending on which direction you're going. And just like we did in our graph, let's go ahead and get our root yaw offset. Just like we did in our anim graph in the state machine, we will say if you're greater than 0, we will select a float. So this will give you an option of different float values to choose. And we'll feed that into the multiplier. So if I did this correctly, A should be -1. So if root yaw offset is greater than 0, we'll multiply by -1. And basically this gives us our value for right or left. So one more time, let's go into here. Okay, and she's still turning, but she's for whatever reason that number is not updating. So let's go back in. And let's make sure we have everything hooked up correctly. So first of all, let's go back to our anim graph.
So many layers.
So many layers.
It's like Inception.
It
You have
really is.
thing inside a thing inside a thing.
Those turns. So for one, we were getting a little bit of logic. The reason she was turning over and over and over again is this max transitions on the idles and turns. We should set this to 1. Okay. That's going to get rid of that. With her turning in place, it seemed like we were not getting the proper offset. Let's go back and check all our, let's check our graph flow real fast. So like I've said on the stream countless times, is this stuff is a lot of times trial and error a little bit. And so it's very common just to kind of leave something off a graph, and it's good to just go back and just double check the flow of everything. So let's get back to where we started. in our initial branch, we're saying, you know, don't turn. We know all this stuff worked because this stuff was backing out. It was backing out just fine when we went, and she would, you know, I'd turn right and she would stay looking forward. So we know this stuff is working. Let's go back up to this graph here, and we're saying, let's just check the spelling of all the curves. So we're saying is turning. If it is, go ahead and the condition is true. Okay, and then let's go to sequence. And bear with me, guys. Okay, so here's our curve value on the do once. I didn't feed anything into it. Basically, I set it at 0. We do not want that. We want to go ahead and get the curve value from the distance curve. So here's a part. I did not connect something. So let's go back and let's test this again.
Yeah, they're also mentioning, I don't know if you already addressed this, but the last node that has one multiplier of -1, and they said the other is 0, and it should be +1.
Yes.
The select float.
That's why I invite you guys to this thing.
We invite
Without
you.
you, I am nothing. All right, no, not 10. That is right. That's that is why one direction was working. So we're super close. We're getting there. Okay, and let's go back and play. Let's go full screen and see it in all its beauty. All right, so we're turning left, and she turned left. We turned right, she turned right. Okay. All right, so I have one last thing to do. I want to show you guys real fast because I'm super short on time. All right, we want to go ahead and get that aim offset working in the anim graph. So remember where I deleted that yaw from the aim offset blend space? We want to get the all-important root yaw offset because this number is doing everything we want it to do, but we want the inverse of that. So we'll do a multiplier. Float times float. We'll just say -1 because we want to invert it. There might be another way to do this. We'll do it this way. Okay, and for the very last step, she is now idle. She's looking left. You can see her head turning left and right. And now if she turns left, she does a turn animation. She turns right, she does a turn right animation.
Woo.
And there you go, guys.
Perfect.
So thank you so much for your help. And
This was awesome.
I'm short on time. I don't think I have time for many questions, but please hit me up on Twitter. I'll be more than happy to answer any questions you have.
Yeah, there were just a couple
Okay.
that we could pull for you really quickly.
Okay.
They're asking, let's see. Sorry. I guess this is nothing in particular with turn flip. So I guess what happens if you turn the camera quickly to more than 180 degrees? Will it catch up, or?
Yeah, let's do it. Yes, it should catch up in this case. Let's see.
Yeah, seems to do all right. And then they're wondering if it's possible to trigger the turn in place, you know, at 45 instead of 90 degrees. I imagine that's just
absolutely.
setting it.
Yeah, the trigger
Yourself.
point is that number I put in the rule set. So the reason I chose 90 is because we animated this at 90. But you can have let's go to the anim graph, and that's essentially just in this rule set for the turns.
Cool.
Yeah, any other questions?
Not about this particular. I know some of you all have additional animation questions. This was specifically a turn in place event, and so if you have more questions, always feel free to toss them out on the forums or reach out to us. I would love to sit here and let you do Q&A with Jay, but we also need to get to our summer UE4 jam announcement.
Nobody wants to know about the jam.
Nobody?
Nobody.
I don't know.
I think they all, like, they've already decided that it's Space Cats.
That's true.
Which,
That was not our theme.
Right, we didn't pick. Did you pick Space Cats?
No.
Did Jay?
Sorry.
Jay picked Space Cats.
It's just
Do you
there
have a
for the
secret
it's there for the
sub-theme?
plucking.
Is it a
It's Schrodinger's
diversifier?
Space Cat.
But no, first of all, thank you so much for joining
Yeah,
us.
absolutely.
I know lots of people have
Absolutely.
been highly anticipating the turn in place.
The all important turn in place. Yes.
They were wondering really quickly, actually, if so. This is not something that will be included in the blueprints that are available on the marketplace.
No, but I'm sure I can put maybe this blueprint up on GitHub or something.
Or we could do
Well,
GitHub, or if we can upload it to the forums and provide a link to it from this chat. So
Mhm.
if you want to see the project all set up.
Yeah,
that
that would be
something we
good.
could do?
I'm sure I left some stuff off here. I'll comment it and we'll put it up for you guys
That's
to,
awesome.
to dissect. That'd
Great,
be good.
thank you so
First,
much.
first sample from Janimation.
Oh gosh.
It's gonna be a thing. I'm gonna make it a thing.
But yeah, so we are super pumped for our summer UE4 jam. This is always one of the quarterly jams are one of my favorite part. We get to play all these amazing games that you all are making. Before we get to the theme announce and all that jazz, we do want to give a huge shout out to all our sponsors. We have crowdforge.io. They've been supplying, they're a platform that lets you find a team. So if you're still in that last minute, like, oh, I
got
gotta
time.
find somebody
Yeah.
or collect a team, you can go sign up there. Lots of great folks. Houdini is also, you might still have time to go sign up for their trial, but our winners will also receive a 1 year Houdini license. Man, words are hard sometimes, guys.
Houdini, 1 year.
Houdini, yep. Quixel is also providing some free materials and scans prior to the jam. So if you haven't gone and downloaded them, there's still time to sign up through either midnight. I think it's midnight tonight. So get over there. They've got tons of amazing products, and we have some really incredible prizes from them. I don't know. I'm jelly of the people that are going to be taking home those
Yeah, Quixel's amazing.
Quixel suites. There's also still time for you to sign up for Perforce or get access through Assembla. So if you shoot us an email at community@unrealengine.com, I'll be sending out invites for you to get that set up. And yeah, we love having them on board. I think one of these days they're going to sit down and really dive in on how to get folks set up with version control. It can save you lots of time and pain setting up these version controls.
Version control is just amazing.
Definitely do that. Soundly is offering a free library, sound library, to all those folks during the jam. So if you're a lot of folks are really bad and do it in the 11th hour,
Right.
but there are a lot of sounds available from them. We're really appreciative to have them on. Aller, the hero of the peel.
The new one. The new
Aller has
edition.
joined us. He's sponsoring with the Daller, and it's a cryptocurrency for those that don't know. And he's going to be playing through all the Game Jam submissions on his Twitch channel. So once the jam's all wrapped up, he'll start playing through, and he's going to he has his own Aller Daller category where he will be picking the most entertaining game. So jump in on that. I feel like that stream's going to be a lot of fun.
And I think he's letting the community kind of get involved in the in the
so it's going to be
process. So
his most
Yeah.
entertaining, but also that
the
his
jive of the
followers
community.
and
Yeah,
audience
I think that's a
support.
really neat, cool.
So
cool
we're
thing.
excited to see him all.
Yeah.
Huge thank you to SB. He's supplying his FPS shooter starter kit. We have Polypixel. It's a really well-known marketplace seller. They have a lot of really fantastic assets, and they're offering all of their available packs
It's insane.
to our winners. So you can get some swanky stuff from them. And again, we have our finalists will be entered into a raffle for a Falcon Northwest laptop. It's one of the most beautiful laptops I've ever seen. And
The backpacks were amazing. Yeah.
we do. We have a handful of backpacks around, and we're all like, "Oh, it's really neat." They're totally like TSA ready, and
Yeah.
that you like.
Oh, I mean, I
open
have
this-
mine.
Oh, ta-da! Yeah,
Ooh.
they're
Yeah.
super swanky, but the laptops
Yeah.
are really nice. It's
That's
a custom
nice.
Unreal Engine branded laptop, and Intel is always one of our amazing sponsors. They're doing the insanely fast. I feel like I always want to do the freaky fast.
Freaky fast.
But the
Finally, freaky fast.
SSDs, they have the Intel Optane SSDs, and they're really nice pieces of hardware. Those will go to all our finalists as well. And you should definitely check out their game dev program. They have this great they're trying to provide marketing resources or information on just how to help you succeed. That's what their game dev program is all about. So if you are a small team that has a game, reach out to them. They're totally here to support you, and we love working with them. So, man, I have a few minutes to kill.
We
Talk
could
about
just-
categories.
Yeah.
Oh, we are
Oh.
doing something new this time. So in the past, we're doing a best mobile game, and not that hasn't been a thing before. So we're doing an on-the-go category, but now you can submit iOS games. I cleared it with our team's QA. Folks say we can totally do it. You have to do a development build, but we can re-sign it and play your games. So if you're an iOS developer, you can now submit mobile games.
That's awesome.
Instead of just doing Android. So we're
That's
really
awesome.
excited to celebrate that. And with all the mobile optimizations that we've had recently, we thought it'd be cool to see what mobile games you all can make. And we're doing the something something reality. I love seeing your AR and VR games. And then Army of One, because it's always impressive. I don't know. I really love the Army of One category. Lets us just see what a solo developer
So
can
that's
do.
just one person,
One person.
doing everything.
Yeah, one person. Yep.
Art,
Knocking it out of game
everything.
Art,
in
music,
5 days.
programming, everything.
5
So
days. Nice. That is an army.
yeah, it's I think a couple of the games last time that were like in the top 5 or so
Yeah.
were Army of One games. It's incredible what those folks do.
are.
I'm going to talk real quick about Twitch, because when you guys are streaming over the next 5 days,
Yes.
we'd love to watch you guys making these games. So if you do stream, you can stream under the Unreal Engine game category on Twitch. So make sure you do that. And if you do that, tag us on Twitter at Unreal Engine, or use the hashtag UE4, because that's during these game jams. That's how I spend my weekends, is watching people on Unreal making stuff in the engine. So I'd love to hang out with you guys. So that said, I think there's no, I think,
Should we just go?
I mean, we could, yeah, you guys, we can cut the stream.
Are we done? I mean, I gotta
You
go
got time.
get
So,
a
all right.
drink, coffee.
Good?
Over the course of the next 5 days, do use hashtag UE4Jam.
Yes.
We absolutely love seeing what you're working on, and it's progress. It's really fun to see the concepts turn into more refined in-progress work, to getting to see your final projects. Like, that is almost an enjoyable journey in of itself.
Yeah.
Like,
It's an interesting
like,
story.
oh, I don't need the game.
Yeah.
I do want to see the game. But key note about needing the game. Many of you, or a handful of you, got tripped up last time. Upload your game to itch.io, but then you also have to do the added step of adding it to the jam page.
Right.
So I know some of you are like, oh, I got it up in the final hour. And then you're like, why is it not on my jam
Yeah.
page? You have to submit. It's a 2-step process.
And make sure you leave yourself time to upload, because we had people last time who tried to upload and it was too big, or internet problems. So
Yeah.
make sure
Compile
you leave
early,
time. Yeah.
Package early.
Yeah.
Give us an early submission, and then if you need to resubmit, you're always welcome to update that
Right.
file up until,
But it's better to
final
have
moment.
something qualified than nothing.
yes,
Yeah.
absolutely.
So even if it's not necessarily, you want to make another change, upload. Just like give yourself 2 or 3 hours to package and upload.
And then if
and
you're
then
keeping
submit.
working, great.
Yep.
Or, go pat yourself on the back
Yeah.
and get some sleep.
Yeah, there you go.
So,
The theme,
are you ready? Are you ready for this?
I think,
Ready?
Yeah.
I'm all ears.
are you?
It's not.
This is, you look very animated.
It's not Space Cats.
It's not Space Cast.
Oh.
Uh-oh.
All right.
All
So, the theme
We don't have a drum roll music.
is... Well, that escalated quickly. So,
All right.
this is your theme. I hope you have lots of crazy ideas. I know that we just had a few fun ones off the bat, so I'm sure, given some fancy brainstorming moments, you're going to come up with some wild and wacky ideas, and we cannot wait to play them. So please have fun, enjoy your weekend, take care of yourself, and we will see you next week.
Oh, and fill out our survey.
Oh, yes,
Yeah.
do the survey,
And get a t-shirts. We sent out the 4 today.
all those things.
Yep.
All right, have a great week, everyone.
All right. Bye, everybody.
Bye.